So the algorithm of the backpropagation, if you go for step by step, it looks something like this. So I hope now it will be clear. So whatever we have done till now, what we have done? First, we have to initialize the synaptic weights randomly. So what is synaptic weights? Synaptic weights means the weights between the neurons. Definitely, it is not possible to understand which will be the optimal weight. That will be evaluated. Optimal weight will come after some sort of learning. So that's why we always initialize the weights randomly. Any value. Now run the network forward with input data and get the network output. So as I told you that we will pass the fed the input, and that input will go through different layers and reaches to output layer. This this is this particular you know activity we call forward pass, because from input to output, forward pass. After getting output, we will start the back propagation of the error, and that is what we call backward pass. From output to input, what is passing? The error is back propagated in some form, of delta, you can say. So if you look into that, you see that in the third step, that for each output neuron, you have to compute delta k, because delta k means what? Delta 1, delta 2. In this way, the delta of all the output layer neurons. Once, and keep it with you. Similarly, you calculate for each and every hidden neurons, the neurons in the hidden layer, you can calculate delta j. But interestingly, if you want to calculate delta j, you have to calculate delta k first. You see, delta k is hidden within the delta j. Obviously, it has to be there. So, once you get this delta k and delta j, now it will be very easy to compute the change of the weight. That is delta wkj and delta wji, and also the change of weight between the bias and the next layer neuron, which is delta theta k1 and delta theta j1. So once you change this, once you find the change, the change of the weight, the delta, you can, what you will do? You can simply add that change value with the current weight, get the new weight. What is happening here actually? The last one is update the weight. So after updating the weight, what will happen? The weights are updated, and then what we will do? We will feed a new data and do the forward pass again. Again we will have some output. We will calculate the error, and then again we will backpropagate the error, and again some weight will be adjusted. And in this way, after a huge level of iteration, maybe you will see that the error will become very close to zero. Once the learning will be proper, the error will become very close to zero. I will never say that error will be zero, because here always remember, this learning algorithm is basically, and to some extent you can say, an optimization algorithm which optimizes the error, which minimizes the error between desired and the actual. It's not that it removes the error fully. It may remove, may not, but it will be very, very negligible. The error between desired and actual will be negligible. Once it will be negligible, it will cross some threshold. Say for example, the error become less than 0.005. Then we can stop learning. That it's enough. That means the model has learned well to generate the data which is very close to the actual result. So this is the whole idea of computing a multi-layer perceptron and do the learning. Now what we can do, we can take a use case, we can take an example, we can try to check what's happening by equations, by implementing the equations, by calculating the mathematics. Okay, so now what we will do, we have an example here, and we will start with the example and do the rigorous calculation and see, we will see that how these weights are adjusted. So anybody have any question?